So yesterday we were just working with permutations. Today we're going to be doing both types, combinations and permutations. So what I want to do is give you a definition of each first. Okay? A combination is an arrangement in which order is not important. So the order that you list things does not matter. Okay? For example, the lottery numbers. It doesn't matter which order that the numbers come out of. All that matters is that you have those numbers, right? It doesn't matter what order they pull them out of.
I thought it had to be in order.
Permutations are a little bit different. A permutation is an arrangement in which the order is important. So order does matter. So, for example, if you are handing out prizes for first, second, and third place, the order does matter, right? It makes a difference if you get first place than if you get third place. Okay? So what we're going to do for the first 8 problems is just determine if it's a combination or a permutation. Okay, that's all we want to do. So let me leave those up. So, number 1, a classroom seating chart. Combination or permutation? For this class, it's a combination, but in real life, what is it? Okay, does order matter? Yes, so it is a permutation. Okay, so remember, permutation order matters, combination order does not matter. So what about number 2? Finding the diagonal of a polygon, permutation or combination? Combination. Okay, let's think about it. When you're doing the Pythagorean theorem, and you know a squared plus b squared equals c squared, does it matter what order you put a and b in?
Yes.
No. The order that you add them doesn't matter, right? Okay. Well, C is on the other side.
Exactly, but when you put C on the other side, that's pretty important.
But we don't know what C is yet. I'm talking about the order that you're adding them in. It's a combination. Okay, thank you, Michael. The batting order of the Pittsburgh Pirates, combination or permutation? Permutation. Order matters there, right? Okay. What about 10 books on a library shelf? In the library, does order of the books matter? Yes, it does. So it is a permutation.
I've never been to a library.
Okay. A hand of 5 cards from a deck of 52 cards. If I have 3 kings and 2 queens, does it matter what order I have them arranged in? No. So it is a combination.
It's just playing Go.
Order still doesn't matter. Okay? Okay. Number 6. A 7-person committee from your class. Is that a combination or a permutation?
What do they mean by committee?
Committee. Like if I took this class and I picked 7 of you to be on a committee, does it matter? It's still a combination because if I pick all 7 of you in this second row, it doesn't matter what order I list you in, it's still you 7, right? Okay, so that's a combination. Now, if it was positions, it would be a permutation, right? But I'm just looking at a committee. Okay, number 7. Number 7. First, second, and third chairs from 6 clarinets in a band. Permutation or combination? Permutation. Order does matter there. Number 8. 16 outfits chosen from 6 outfits chosen from 14 outfits to be modeled. Does the order matter there? I'm just picking the outfits. I'm not putting them in order. I'm just picking which outfit. So does the order matter? Combination. Okay, combination. The order does not matter. It just matters which 6 I picked. Okay, now combinations. We do have a formula just like we did for permutation. So now we're going to be given problems where we have to determine if it's a combination or permutation and then pick what our equation is going to be. Okay, now remember, we can write combination in 2 different ways. We can put n combined r different ways, or the combination of n and r. So it can be written in two different ways. The formula is very similar to permutation, but with one slight change. So we still have n factorial, the number of choices, over the difference of the two, n minus r factorial. But for a combination, you need to multiply that by r factorial as well. Okay? And then we will write them all out and see what cancels, and that's it. So 1 through 6 are just a bunch of combinations, no word problems yet, but we just have to plug them into the formula. So number 1, I have 5 different possibilities. We want how many combinations of 2? So all we have to do is plug it into the formula. The first number is my n, so this is 5 factorial over 5 minus 2 factorial, which gives me what? 5 minus 2 is? 3 factorial times r factorial, so that's going to be times 2 factorial. What do you notice about the top and the bottom? They add up to 5, right? The bottom should always add up to the number on top. Okay? Okay, so we're not done yet. We need to expand it. What does 5 factorial mean?
5, 4, 3, 2, 1.
5 times 4 times 3 times 2 times 1 all over. What's 3 factorial? 3 times 2 times 1 times 2 factorial. 2 times 1. Okay, let's do some canceling. What cancels here? 3, 2, all the 1's cancel, right? Okay, anything else that at least reduces? 2 goes into 4 how many times? Twice. So I'm left with 5 times 2, which is 10. And that's the answer. There's 10 different ways that I can make groups of 2 from 5 choices. That's all this is saying. So I have 10 choices, and I'm picking them in groups of 5. So how many combinations do I have? That is 10 factorial over 10 minus 5 gives me 5 factorial times 5 factorial. Okay, 10 factorial is what? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 5 factorial is 5 times 4 times 3 times 2 times 1 and 5 factorial again, so times 5 times 4 times 3 times 2 times 1. Okay, yes you are. What cancels here? 5, 4, 3, 2, all the 1's cancel. Anything else cancel or reduce? 5 goes into 10 how many times? 2. Anything else? 3 goes into 9 3 times. You could also do 3 and 6. What about 4 and 2? What is 4 times 2? 8. So that cancels completely with the 8, right? So we are left with 2 times 3 times 7 times 6, which gives me 252. Number 3. I have 12 choices. I'm picking them in groups of 7, so let's write it out first. That's 12 factorial over 12 minus 7 gives me 5 factorial times 7 factorial. Okay, let's think about this really, really quick. 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. What do we know about 7 factorial? 7, 6, 5, 4, 3, 2, 1. So we know that we can, the 7 factorial is going to cancel out with 7 on from 12 factorial, right? Every single thing. So I'm not going to write it. It cancels out. 5 factorial is 5, 4, 3, 2, 1. And now we can reduce some more.
Wait, how come we get rid of the 5? There was a 5. So we
Okay, so what else reduces here?
5, 2, and
5 times 2 gives me 10, so that's going to cancel with the 10 completely. Anything else? 4 and goes into 8 2 times.
Couldn't you just do 4, 3, and 12?
Yeah.
You could also have done 4, 3, and 12. I didn't write it that way, so I'm going to do it this way. As long as you are reducing consistently, you should get the same answer no matter what. Okay? So for mine, I got 12 times 11 times 3 times 2, 792. Okay? Okay, so number 4 is a permutation, which is what we did yesterday. We have 10 objects, and we want to permutate them 4 times. So we're picking 4 at a time. But in this case, the order does matter. So the formula is a little bit different. It's still n factorial on top over 10 minus 4, which gives me 6 factorial. So the bottom is n minus r factorial, but we don't multiply by r. So note it. Remember how combination is on the bottom n minus r factorial times r? For permutation, it's just n minus r factorial. Okay? So we know some things about this one. 10 is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 6 is 6, 5, 4, 3, 2, 1. So the 6 is going to cancel out with everything from 6 on, right? So it's going to be 10 times 9 times 8 times 7. And everything else is already canceled out.
5,040.
Which gives me 5,040.
There's no labels or anything?
Nope. We don't know any units. Okay, so number 5 and 6 are a little bit different. Okay, because we have 2 combinations and then we're multiplying them. So what we need to do here is we need to do both combinations separately and then multiply our answers together. Okay, so if I have 12 choices and I want to know how many combinations of 4 I can make, let me zoom this in. What would that one be? Okay, if I have 12 different choices and I want to know how many combinations of 4 I can make, that's 12 factorial over 12 minus 8, which gives me, or 12 minus 4, which gives me 8 factorial times 4 factorial, times 8 factorial over 5 factorial, 3 factorial. We will be able to cancel some stuff. 8 minus 3 gives me 5. Okay. Okay, 12 factorial. Let's look at this one. In the first combination, I have 12 factorial over 8 factorial. So what's going to cancel out there? 8, 7, 6, 5, 4, 3, 2, 1, right? Yeah. So what would be left of the 12 factorial? 12, 11, 10, 9, and I can stop, right?
Yeah.
What's left of the 4 factorial? 4, 3, 2, 1. Hold on. I want to rewrite the second one first. Okay, what about 8 factorial and 5 factorial? Some stuff cancels there, right? 5, 4, 3, 2, 1. So what would be left of the 8 factorial? 8, 7, 6, right? All over. 3 factorial is still left over, so 3, 2, 1. Okay, 3 factorial. Did not cancel. Okay, looking at the first combination, what's left over? What cancels there?
4 and 3.
4 and 3 make 12, right?
And then the 2
and the 2 goes into 10 how many times? 5. Okay. What about, so that gives me 11 times 5 times 9, which would be 495, times, okay, how does this reduce at all?
The 3 and the 2 go into 6.
3 times 2 gives me 6, so that reduces with 6 the whole way, right?
Yeah, and then the 1's just opposite.
And then the top is just 56. So what is 495 times 56?
27,720.
27,720.
Got that right. Yeah.
So now this is more of what we're actually going to see here. We have word problems, and we're going to have to decide if these are combinations or permutations. So reading example 1, how many committees of 5 students can be selected from a class of 25? Does the order matter here?
No.
No, it just matters whether or not you're on the committee. So this is a combination or a permutation?
Combination.
Good, combination. So how many students do we have to choose from?
25.
So that's a combination of 25 choices, and we want to pick 5. So let's plug it in. That's 25 factorial over 25 minus 5 gives me 20 factorial times 5 factorial. Okay, and remember, the denominator should add up to what the numerator is. So 20 plus 5 gives me 25. Okay, a whole bunch of stuff cancels here, which is really going to help us. That 20 factorial is all going to cancel out, right?
Mm-hmm.
So what would we be left with on top? 25, 24, 23, 22, 21. All over. Okay, so what's 5 factorial? 5, 4, 3, 2, 1. Okay, what cancels or reduces here? 5 goes into 25 5 times. 4 goes into 24 6. 3 goes into 21 7 times. And 2 goes into 22 11. So we are left with, I'm just going to rewrite this all out. 5 times 6 times 23 times 11 times 7, which gives me 53,130. You may use a calculator, however, I still need to see this amount of work. Yeah. Alright, example 2. How many ways can first, second, and third place be awarded if 20 people are running in a race? Does order matter here?
Yeah.
Yeah, so is this a combination or a permutation? Permutation, so let's write it out. How many people do we have to choose from? 20. Permutated, how many different places? 3. Okay, now remember, permutation is a little bit different. That is 20 factorial. 20 factorial over 20 minus 3, which gives me 17 factorial. Okay, this is nice for us because 17 is going to cancel with 17 on down from 20 factorial, right? 17, 16, 15, all the way to 1. So this is only 20 times 19 times 18, and we can stop there.
6,840.
So what'd you get?
6,840.
6,840. Good. Okay. All right, example 3. A box contains 12 black and 8 green marbles. How many ways can 3 black and 2 green marbles be chosen? Now this is a little bit different. What type of problem do you think this is going to end up being? It is a combination because the order doesn't matter, right? It just matters whether you have black or green marbles. But I have 2 different combinations going on here, right? So we're going to have to multiply them together. What's the first combination? Let's do black marbles. 12, C, how many are we choosing? 3. Times green marbles, how many green marbles are there? 8. Combination, how many do we want to choose? 2. Okay. So this is 12 factorial over 12 minus 3 gives me 9 factorial times 3 factorial times the second combination is 8 factorial over 6 factorial 2 factorial. Okay, let's look at the first combination. What can cancel here? 9 on down, right? So we are left with 12 times 11 times 10 over 3 times 2 times 1 times, what about 6 factorial and 8 factorial? 6 down, so that's 8 times 7 over 2 times 1. Okay, looking at the first combination, what cancels here? 3 goes into 12 4 times. Anything else?
2 goes into 2.
2 goes into 10 5. Okay, what about 2 goes into 8? 4 times. Okay, so 4 times 11 times 5 gives me 220. Times 4 times 7? 28. 6,160. Still okay so far? Okay. Okay, so the first combination, we'll do boys first. So there were 12 boys to choose from, and we wanted to pick 5. Times 10 girls to choose from, and we wanted to pick 5 girls also. Okay, so that is going to be 12 factorial over 12 minus 5 gives me 7 factorial, 5 factorial, times 10 factorial over 10 minus 5, 5, and then 5 factorial, equals, now that 7 is going to cancel out with 7 down from 12, so that's 12 times 11 times 10 times 9 times 8, all over, we still have 5, 4, 3, 2, 1, times 10 factorial, and it's going to cancel with 5 down from 5 factorial, so that's going to be 10, 9, 8, 7, 6, times 5, 4, 3, 2, 1. And then we have some canceling we can do, and you can do your canceling any way. I'm noticing that 5 times 2 gives me 10, and 4 times 3 gives me 12, and that's everything from the first combination. So I have 11 times 9 times 8, which is 792, times. Down here I'm noticed that I have 3 and 2, which gives me 6. 4 goes into 8 twice, and 5 goes into 10 twice. So that's 2 times 9 times 2 times 7, which is 252. So when I multiply both of those together, I get 199,584 different combinations.